Hey, hello, welcome back to the channel. In this video we're going to see about classification of carbohydrates. So carbohydrates are otherwise called as saccharides or sugars. Now I have made a flowchart on the classification of carbohydrates. The first one is monosaccharides, and the second one is oligosaccharides, and the third one is polysaccharides. So first we'll move on to monosaccharides. So mono, the term mono is nothing but single, or you can call it as one. Okay, so saccharides are sugar units. So here you'll be having only one sugar unit. That's why we are calling this as simple sugars. So only one sugar unit will be present in case of monosaccharides. So again, this monosaccharide is again divided into two. One is on the basis of functional group and another one is on the basis of number of carbon atoms. So on the basis of functional group, we have got another two branches here: aldosis, ketosis. So aldoses are nothing but, you can find the aldehyde functional group here. Okay, you can find the aldehyde functional group in the sugar unit, and in case of ketosis you'll be able to find out the ketone functional group in the sugar unit. Okay, so functional groups are nothing but a group of atoms, or you can call it as a molecule, which is present in a chemical compound, and that functional group will be having their own properties. Like for example, if you take alcohol, OH is the functional group. Okay, aldehyde, CHO, ketone, C double bond O. Okay, so likewise there are different functional groups which will be present in a chemical compound, and that will be having their own properties. Okay, now if you take aldehyde group, like in case of aldoses, I have taken the example as glucose. So if you check the structure of glucose molecule, you will be able to find out CHO functional group in it. Okay, so whichever the sugar units consist of aldehyde group in it, that will be coming under aldoses. And at the same time, if you take example as fructose under ketosis, you will be able to find out the keto group in it. Okay, so these are the two under functional groups, like on the basis of functional group. Okay, so there are different example. I have mentioned one here for aldoses, glucose, and for ketosis, fructose. Now coming to the number of carbon atoms, on the basis of number of carbon atoms, again you have got four divisions. The first one is triosis, which is nothing but three carbon atoms. Tetrosis, tetra is nothing but four, so here you are having four carbon atoms. Pentosis 5, and hexosis 6. Okay, let us see the examples. So for triosis we have got glyceraldehyde as example. So the formula for glyceraldehyde is C3H6O3. Okay, so this is the formula for glyceraldehyde. Can you see three carbon atoms are present here? Okay, and then tetrosis, for example, erythros. If you take erythros, the formula for erythros is C4H8O4. Okay, so you can see here four carbon atoms are present. And ribose, coming under pentosis, so you'll be having five carbons here, so C5H10O5. You can see five carbon atoms here, and again six carbon. Glucose, so we know the formula for glucose, C6H12O6. So you can see six carbon atoms here. Okay, so this is on the basis of number of carbon atoms. I think you're clear with monosaccharides. So in case of oligosaccharides, you will be having 2 to 10 sugar units connected. Okay, so in case of mono, only one sugar unit was there. Okay, in case of oligosaccharides, what is happening? 2 to 10 sugar units are being connected with each other. Okay, so this is again divided into 4. Okay, so disaccharides, di is nothing but 2, trisaccharides 3, tetrasaccharides 4, pentasaccharides 5. Okay, you know what is meant by saccharides? It's nothing but the carbohydrates or sugar. So two sugar units are combining together, and in case of trisaccharides 3 sugar units are combining together, tetra 4 sugar units, penta 5 sugar units are combining together. Now let us take an example. So I have taken maltose, let me write it as M, and then lactose and sucrose. So if you're taking maltose, it is disaccharide. That means two sugar units have combined together. So what are the two sugar units? So glucose plus glucose. Two glucose sugar units have combined to give maltose. Okay. And in case of lactose, one glucose sugar unit and another galactose sugar unit have combined together to give lactose. And in case of sucrose, you have got one glucose and one fructose. Okay, so this is disaccharide where you have got only two sugar units combining together to give a compound. Now coming to trisaccharides, I have taken the example as raffinose. Okay, so this raffinose will be made up of three sugar units, that is galactose plus glucose plus fructose. Okay, and then tetrasaccharides, example stachyose. Okay, so this stachyose will be made up of four sugar units, right? So here we have got two galactose and one glucose and one fructose, right? And then pentasaccharides, that is verbascose, it will be having five sugar units here. Okay, so what happens here is we'll be having three galactose and then one glucose and one fructose. Okay, so this is the combination. So this is about the oligosaccharide. Now let's move on to polysaccharides. So here we have got more than 10 sugar units in a compound. Okay, so all like more, for example, if it is 12 sugar units, all the 12 sugar units will combine to give a one particular carbohydrate. Okay, so now this is again divided into two. One is Homo polysaccharide and another one is Heteropolysaccharide. So Homo, the term Homo is nothing but same. Okay, that means same kind of sugar units will combine together to give one particular carbohydrate. And hetero is nothing but different. So in this case, different sugar units will combine together to give one kind of polysaccharides. Okay, so now let us take an example, cellulose, which is coming under Homo polysaccharide. So if you take cellulose, let me write down the general formula like C6H12O6. So this is glucose. We know this already, right? So this glucose, it is there in N number. Okay, so this N represents 11, 12, 13, 14, 15. It goes on. Okay, so a number of glucose units combine together to give cellulose molecule. Okay, so this is coming under Homo polysaccharides because only C6H12O6 is there. Only glucose units are there. Different units are not being involved here. Okay, now when it comes to heteropolysaccharides, let us take peptidoglycan as example. So in case of peptidoglycan, here we have not got only one type of sugar unit and one type of chemical compound here. Different chemical compounds are involved here. So in case of peptidoglycan, we have got sugars and as well as we have got amino acids in it. Okay, amino acids, it's a group of chemicals which combine to give proteins. Okay, so sugars and amino acids combine together to form peptidoglycan. Okay, so that's why we are considering this as hetero, that means different sugar units and as well as different chemical compounds are involved here. Okay, and if you take chondroitin sulfate, you will be having a chain of alternating sugars. Okay, different types of sugars will be combining together to give chondroitin sulfate. Their amino acids are not present, only different types of sugars are combining together to give chondroitin sulfate. Okay, so this is all about the classification of carbohydrates. So you can have a look at this flowchart. So this is the way I have designed this. So if you want, you can also try to make it, and it would be easy for you.